Right, year 10, so I'm trying to get your head around the idea of how we calculate uncertainty and how we deal with results in this new style of report. So what I've done up here is a little fake data set with, I did the experiment earlier, where I had a ball, I dropped it from a height 60, 80, 100 and 120 centimetres and recorded the bounce height. I've conducted 3 trials, okay, so that's my raw data. I'm going to show us how we should go about analysing that and how we should set up a table. So first of all, I've got my independent variable, my dependent variable, all my trials here, my average, my absolute uncertainty and my percentage error. So that's how you probably want to set up your table because it makes the most sense to do it that way. Before we go any further, I want to show us how we can calculate our average. Now to do that you'll need a calculator. For those of us who are a little unsure, the average calculation in this situation is, because I've got 3 trials, I have trial 1 plus trial 2 plus trial 3 divided by 3. Be aware that there are brackets around these. Okay, if you just shove that into your calculator, it'll divide trial 3 by 3 and then add up trial 1 and 2. So we need to be very careful with our calculator skills when we're doing this. So I'm just going to quickly go through and show you how quickly you can calculate your averages and hopefully get us going in the right direction. You could obviously use Google Sheets for this if you'd like, but I'm going to show you how to do it without it. So 41 plus 42 plus 42 divided by 3 equals 41.66 or 67. So I'd put 41.67 centimetres. I don't need centimetres because I've listed that above. 57 plus 54 plus 61. Divide that by 3. 57.3. It's probably a good idea to go along and do this at home so you've got an idea about how to do this on your own. 71 plus 74 plus 72, divide that by 3 equals 72.3, and I should make them 3, keep the decimal places. The last one is 96 plus 98 plus 81, divide that by 3, 91.67. Okay. Now I want to highlight a few things here. That's how you calculate average, but before I did that I probably should have sat down and had a look at my data and see whether I've got some anomalies or anything that looks a bit different. Now if I go across each one of these tables I can see that the average is pretty close to each one of my trials, which is a good indication, all except for this last one of 91.67. Okay, that one is clearly not that close to 98 and not that close to 81, which tells me that I've probably got an outlier. I'd look at my 3 data points and pick which one looks the most different in this scenario, and I can see that 81 is an outlier. So if that was my data, I would highlight it, and I'd either, depending on the size of the outlier and how reliable I think it is, I'd either include it or exclude it from the average calculation. I'm just going to leave it in there for now and then deal with it as an uncertainty to show us how to deal with that. So that's how we calculate average. There's nothing new there. I assume that we're all pretty solid with that. So let's come across to some uncertainty. So the absolute uncertainty in our table, so when we've collected data, to find our absolute uncertainty, we look at our max value from our trials and subtract it from our min value from our trials. And we're just looking for a total number. Okay, so our absolute uncertainty in this scenario is found, and probably the easiest way is just to go across and have a look. So the first thing I want to do is identify my max value in each row, and then identify my min value. So in the first one I've got 42 and 42, they're both my max value, so I can pick either one, and then obviously 41 is my min value. So absolute uncertainty is 42 minus 41, which equals 1. In my second table, my max value is, second test, my max value is 61. My min value is 54, so 61 minus 54 equals 7. My third table, my max value is 74, my min value is 72. My min value is 71, so that's what I know. 74 minus 71 equals 3. And in my last one, my max value is 98 and my min value is 81. So 98 minus 81 equals 17. So you can tell already that the outlier is having a massive impact on our absolute uncertainty. Okay, so that's telling us the uncertainty means how sure of our results are we, or what's the difference between our different tests. So here, the more trials, the more idea you'll get about that. So I've got 1, I've got 7, I've got 3, and I've got 17. Now to calculate my percentage uncertainty, and this is probably, because what should happen as you go further down is the absolute uncertainty should get bigger as the values get bigger. But that doesn't mean the percentage error or percentage uncertainty is any more severe. So for percentage uncertainty, what we're looking for is our absolute uncertainty, which is the value we just found, divided by our average value. Okay? And then we multiply that by 100 to represent that as a percentage rather than as a decimal. So if we come over here, my percentage uncertainty is equal to my absolute uncertainty, which is 1. So I don't even need to write the equation. I just write 1 divided by my average, which is 41.67 times 100, and you'd need a calculator for that. And that, I might read that a little bit smaller so I've got room. So I've got 1 divided by 41.67 times 100. Okay, and the second one, I'll just go through and do them all. I've got 7 divided by my average value of 57.33 times 100. My third one, I have 3, which is my absolute uncertainty, divided by my average, which is 72.33. Again, times that by 100. And the last one, I've got 17 divided by 91.67 times by 100. And I'll find each of those values and sub them in. This is where you'll need your calculator. 1 divided by 41.67 times 100. So this one has an uncertainty of, percentage uncertainty of 2.4%. I'm just going to round it 1 decimal place. 7 divided by 57.33 times 100. This equals 12.2%. 3 divided by 72.33 times 100 equals 4.15%. The last one is 17 divided by 91.67 times 100 equals 18.5%. Okay, so we can see there that our percentage uncertainty varies as we go through the experiment. That's fine. Obviously with this value here, that seems pretty large, so we might want to consider removing our 81 and seeing how that impacts our uncertainty. We'll talk about how we deal with those in graphs, but the main thing is you can get to that point with your graph and you can create a percentage and an absolute uncertainty purely by looking at the values you've collected. You don't have to do anything else except for the mathematical analysis we've looked at today.